Welcome to the Cumulus Networks video overview series on OpenStack. In this video, we're going to talk about building EVPN networks for OpenStack and how we can leverage EVPN for both layer 2 VLANs to the servers, as well as layer 3 VXLANs across the infrastructure. So within an OpenStack deployment, I'm going to have spines and leaf network switches, as well as my servers where my VMs will be deployed. Traditionally, OpenStack Nova, which is used for compute, will deploy VMs as necessary on my servers. And it's the job of Neutron to build network services to connect to those virtual machines. And there are multiple options on how to do this, which include VXLAN on servers, which we'll talk about in a later video, the ability to provision the leafs or the spines using ML2 for VLANs or VXLANs, or using EVPN as an option. And for networks that are scaling within 1,000 or 2,000 tenants, this can actually be the simplest way to deploy is with EVPN. And so the way this works is that on all of my top-of-rack switches, I'm going to provision layer 2 VLAN trunks on all of my server ports. Even before those tenants exist on those top-of-rack switches. As a virtual machine is provisioned, an OpenStack Neutron builds my network connectivity. It will provision, using the ML2 plugin on the server, the appropriate VLAN to connect into that top-of-rack switch. But I still have to build my infrastructure between my leaf and spine network on how to get from top-of-rack to top-of-rack. This is where EVPN can come in. As I pre-provision those VLAN trunks from my top-of-rack switch down to my servers, I can also pre-provision VXLAN tunnels between my top-of-rack switches. So from a network point of view, the entire infrastructure is pre-provisioned and ready to go for whatever OpenStack Neutron provisions from a tenant perspective. And it's going to be the job of EVPN using BGP across this infrastructure to advertise the information about these VXLAN tunnels. This means that I can provision VXLAN tunnels on a top-of-rack switch and allow eBGP EVPN to advertise this information across the environment, whether I only have one other leaf or if I have 1,000 leaves. And so BGP EVPN carries that information that allows VXLAN tunnels to exist from top-of-rack switch to top-of-rack switch. Those VXLAN tunnels tie directly to the VLANs that are provisioned as trunks down to those servers, and ML2 only provisions the server component. In a previous video, we talked about using ML2 on top-of-rack switches, which we support and Cumulus does have an ML2 plugin for, but it's important to remember that the ML2 state that is configured, that networking of VLANs or VXLANs from ML2 and OpenStack Neutron, is totally ephemeral. And what that means is that should that leaf fail due to a power outage, a reboot, or a system crash, I would lose all of that ML2 programming of the VLANs or VXLANs in the environment. So by pre-programming my networks both from a VXLAN L3 ECMP perspective, as well as a VLAN layer 2 trunk perspective, I never run that risk. And I only have ML2 on my servers where those compute resources live. And this is why deploying from 1 to 2,000 tenants or less, an EVPN-based solution can actually be the simplest, most scalable method to build a stable foundation for OpenStack. Look for the other videos in this series that include talking about VLANs and VXLANs, an overview of building spine and leaf networks, and an introduction to OpenStack Nova for compute and Neutron for networking.